What's up, everybody? Welcome to your first geometry video. Today it's Unit 1, Lesson 2. We're going to be talking about segments, and we're also going to be talking a little bit about angles. Now, my structure for the video, I'm not going to read every single thing on the notes. I think you guys are old enough and responsible enough that you can do that on your own. So anything I skip over, make sure you guys read it carefully and pull out any information that you think you might need. So in this first cluster of notes, the first thing I want to focus on is distance. There will be a distance formula that you will be expected to commit to memory. For the SOL, we're going to get into that a little bit later today, but for now I just wanted to show you distance. Okay, it is the amount of space between 2 points. So anytime we're talking about distance, as you can see on this segment, distance is also length between 2 points. Okay, and I wanted to highlight the absolute value sign. Okay, so to find distance, you have to subtract. It's the difference between 2 points. But I also want to highlight the fact that it's an absolute value. I want you guys to take a second and think about what that means, and we're going to address that actually on the next page of these notes. A couple things. So things are pretty simple here. Point B is between points A and C. Point E obviously would not be between points D and F. Okay. Now we got the segment addition postulate. Okay. You guys can read over that on your own, but pretty much what this is saying is that the bigger segment, so AC for instance, is made up of the two smaller pieces. So AB plus BC would give you AC. Okay. And obviously you can use algebra to kind of rearrange that any way that you want. For instance, if we subtracted BC from both sides, then we would have AB, so a piece of the segment is AC, the total, minus BC. So the segment addition postulate is pretty much how you are going to find the lengths of segments. So if we look at this first example, we have collinear points, which means, as you guys learned probably yesterday, that the last class, that they all lie on the same segment. DE is 2, EF is 3, and DE is equal to FG. So in geometry, we're going to use a series of kind of symbols and hash marks to denote when things are equal to each other. So DE is equal to FG. So these tick marks indicate that both DE and FG are the same length. So that means FG is going to be 2 also. Okay. And now from here, you can find the length of different segments. So take a second, find FG, DF, DG, and EG. You should have gotten 2, 5, 7, and 5. Okay, moving on to the next page of notes. We have collinear points again. We have HK. So from here to here is equal to 9. So the whole thing is equal to 9. Okay. We know that HI and JK are equal to each other. So here I'm using single hash marks instead of double. But it represents the same thing. It means that they're the same length. And we have IJ is equal to 1. find the following lengths. Now, you're going to have to use some intuition here, a little bit of critical thinking to kind of figure out some of these lengths. Okay? HI equals JK. So a way that you denoted this in algebra, you could say that they're both equal to X. Right? So they're the same number, so they both would be denoted with the same variable. So we got the total is 9, right? And that is equal to HI, X, plus JK, which is also X, plus IJ, which is 1. So you can kind of use some algebra, figure out what X equals, and then you can figure out the different lengths. So take a second and figure that out. While you figure those out, let's take a second to figure those out. Then we'll move on. So you should have gotten X is equal to 4, right? After you solve that all out. That means H, I, and JK are both 4. And then from there, HJ, 4 plus 1 is 5, and IK, 1 plus 4 is 5. Okay, so here we have the big remember. Remember, distance is always blank. This is what I kind of asked you to think about on the previous page with the absolute value. Okay, so kind of think about what absolute value means. Okay, distance. You know, if you're thinking about walking a distance, or measuring a distance, right? I will give you an A for the whole year if you can go outside to the track and show the whole class how to run a negative mile. That doesn't exist, right? Even if you run a mile backwards, you're still going in a positive direction. So distance is always positive, is the takeaway. You always have positive miles, positive inches, positive centimeters, etc. It's always positive. It has to exist. So now we're talking about looking at distance on a coordinate plane. So let's try to find the distance, the length of these segments. So we got 0, 0, 4, 0. Obviously, you can count the lines and you would get 4. We got 0, 0 to 0, negative 5. So 0, 0 again to 0, negative 5. You can count the lines, the grid. On the grid, you get 5. Negative 3, 2 to 5, 2. Again, you can count the grid, the lines on the grid. You would get 8. And 3, negative 4 to 3, 4. So 3, negative 4 to 3, 4. Count the lines, you get 8. And finally, we have negative 2, 1, and 1, negative 3. So you guys should be noticing that there's something different about this one, right? Before, they were either going, the points were horizontally across from each other or vertically up and down across from each other. But these 2 points are diagonally across from each other. That makes calculating distance a little more complicated because you can't just count the lines because it crosses over, it cuts over. They're not equal measurements. So let's see, how do we figure this out? Well, here we have it. Distance formula. Okay? So this is the formula that you're going to want to commit to memory, especially for the SOL, because you will not be given it on the SOL. But it's how you find the distance between 2 points on a coordinate plane when they're diagonally across from each other. So when they're not perfectly horizontal or perfectly vertical. And what you do here is you take the 2 points, you find the x's. This would be x1, this would be x2. Okay. y1, y2. And you plug them into this formula. So you have the square root, big square root, of x2 minus x1, which is just the distance between the x's, squared, plus y2 minus y1, which is the distance between the y's, squared. And then you'll either get a whole number if it's a perfect square, or you'll get a decimal. Okay. So I'm going to show you how to do that on the next page. I'll give you an example. Actually, why don't we just do this one here? Okay, so we got, I'm going to write on the grid because I don't have space, but we got, let's do these in different colors. So we got x1, x2, y1, y2. So we would have square root squared plus squared, x2 minus x1, well, that would be 1 minus -2. And then y2 minus y1, that would be -3 minus 1. Okay, and 1 minus -2, that's going to turn to 1 plus 2. So we got 3 squared plus -3 minus 1, that's going to be -4 squared. So mathematically, the squares are why the distance will always be positive. Because you have -4 squared, -4 times -4, that's going to end up being positive. But for our last kind of step, we have 3 squared is 9, plus -4 squared is 16. Okay, and that is going to be equal to square root of 25, which is 5. So that's an example of how you would apply the distance formula when your points are diagonally across from each other. One quick note before I let you guys practice. There's a difference between lengths being equal and segments being congruent. So essentially, they kind of mean the same thing. Okay. If you see this symbol, that means congruent. A way you can think about it is lengths are measurements. They're numbers. 4 is equal to 4, for instance. Saying something is congruent are saying that the objects are congruent, or the shapes are the same. So that's one way you can kind of think of it. Okay. I want you guys to do exercises 1 through 3 on your own, and also using the distance formula to find the length of segments. I want you guys to kind of complete that on your own. 4 segments you should be looking at. BA, find the distance. AC, find the distance. AD, and there's actually one more, BD. So go through, do the 3 exercises and find the length of all those segments. on your own. I'm going to move on to angles. So I'm sure you guys all know what an angle looks like. Two rays that have the same initial point. We call that initial point the vertex. That would be an example of vertex. And we have something like this, right? That's an angle. Angles that have the same measure are called congruent angles. And again, measure is going to be the same number. They're both equal, for instance, to 50. But angles are congruent are the objects being the same. Or that's a way you can think about it. Okay. Finally, there's a lot of kind of vocab on this page. Most of it you're probably familiar with, so go ahead and read over this whole page. The last thing you have to do, or I want you to do, is name the angles in this figure. There should be a total of 3. I'll give you one for an example just to show you how we write it. So one angle we could say is angle RQS. So that would be this one. All right. And then there should be 2 more that I want you guys to get on your own. So name the angles and then do the distance questions in the notes. Please ask for assistance if you need it and show it to me when you are finished. This is the end of your first geometry video. Hope you enjoyed.